Today we're offering three different alternative ways of finding the derivatives. So again, derivatives, we've seen it a lot now. It's the instantaneous rate of change. And we want to find derivatives. As I said, we're going to look at three new ways of finding the derivatives. The first one is an algebraic way, and it's using something called symmetric difference. So what we've done in the past, and this should look familiar, we've said, okay, let's suppose we have a point A, and I want to find the derivative. I want to find f prime of A. And f prime of A, that's the f prime of A is the slope of the tangent line. So if I want to find f prime of A, what I've done in the past is I said, okay, let's choose a point A plus h, really close to it, where that distance h is really small. And I've approximated f prime of A as the limit, as h approaches 0, of f of A plus h minus f of A, again just using the slope equation, all over A plus h minus A, or all over h. Well now, just to make this, to provide a potentially even more accurate representation of the derivative, we could also look at the point h to the left of A. So we could look at this point here, A minus h, and the corresponding y value, which would be f of A minus h. And we want to find that slope. So to find that slope, we would say f of A, this y value here, minus f of A minus h, this y value here, all over A minus h, which simplifies to h. And again, we're letting h get really, really close to 0. So then we have these two different approximations for the derivative at A, and they're two different because one is looking at h to the right, and one is looking at a point h to the left of our point of concern, A. And so what do you think we're going to do? We've got these two different representations for the derivative, one to the right, one to the left. Probably the most accurate way to approximate, if we want to approximate f prime of A, let's take their average. So in both cases, we're looking at the limit as h approaches 0. And now I'm just going to add these two together. So f of A minus f of A minus h over h plus f of A plus h minus f of A all over h. And we're taking the average, so we're going to divide that by 2. So now let's combine this. We're saying f prime of A equals the limit as h approaches 0. Well, we've got an f of A minus f of A. So those are going to cancel out. And if I sort of rearrange these orders so that we have a positive and a negative, we get f of A plus h minus f of A minus h over h over 2. And now we're just dividing. We've got, a fraction divided by a fraction, so I can put 2 over 1. And we know what to do there. So that now we get our symmetric difference equation, which is that the derivative of a point can be approximated by the limit as h approaches 0 of f of A plus h minus f of A minus h over 2h. This is just an alternative method to finding the derivative at a point. And just to see what this looks like or graphically rather, we just developed this equation, the symmetric difference for finding derivatives. And what it is, we just found is f prime of a, so the derivative of our function at the point a equals the limit as h approaches 0 of f of a plus h minus f of a minus h all over 2h. But what does that look like? Well, I mean, let's think about it. We've got some graph, just some random graph here. And let's choose the point A. And then we're going h units to the right, h units to the left. So this formula above is just the slope between this point and this point. Because that's f of a plus h. This is f of a minus h. This distance, that should have been a minus there. This distance between these 2 points, well, it's h to the left and h to the right, so that's 2h. So the slope of this line, and the slope is f of a plus h minus f of a minus h all over 2h, what we had up there. You know, why is this helpful? It's helpful because it averages the slope to the right and to the left, just in case some weird stuff is going on. And we'll talk about this more tomorrow, but this is a new technique for finding the derivative, algebraically. The next 2 techniques require the use of the calculator. And now that we have a good understanding of what a derivative is, we can use the calculator to find that almost instantaneously. So let's suppose that we wanted to find the derivative of a function. Let's say that we've got the function equals x squared, and I want to find f prime of 3. Well, how do we do that? So what we can do, I'm going to write the steps here and then use the calculator in a second. So again, this is using calculator. So the steps, the first thing you do is put f of x into y1. And the next thing you're going to do is we're going to use a function on the calculator called nderiv, which calculates the deriv. So on your TI-84 or TI-83, and for some of you guys who have more sophisticated calculators, I can show you this at another time. The 89 or the Inspire can do this much faster, but we're using the 83 and the 84 right now. So what you can do is on your calculator, you're going to press the math button, and then press the numbers button, and then you're just going to go down to where you see nderiv. And when you do that, press enter. And what our calculator can do is it can take the derivative of any function that we have put into y1. And the way that the keystrokes are, we've got this function nderiv, which says take the derivative, parentheses, and you're going to put y1. And what that means is take the derivative of whatever's in y1. And we want to take the derivative when x equals 3. And we're taking the derivative with respect to x. I realized I just made a small little mistake. The order was wrong. So as soon as I said it, I was like, oh, that's not right. So we're using this derivative function on the calculator, and we're taking the derivative of whatever the function is that we've placed in y1. You're always going to have this x, and that's saying that x is our variable. And for the calculus that we're doing this year, it's single variable calculus. We're not going to have lots to choose from. So you're always going to put x. If you didn't want to calculus into multivariable calculus, there, as the name implies, there's many variables. So telling the calculator which variable that we're concerned with is of greater importance. But here, we're just taking the derivative with respect to x. So derivative with respect to x. But we want to take the derivative of the function that's in y1, and that's x squared, and we're taking the derivative with respect to x, and we want to take the derivative when x equals 3. So what's the instantaneous rate of change when x equals 3? So this is the keystroke. We have y1, x, and 3. And some of you may be wondering, how do I put y1? So the keystrokes on your calculator for that are go to vars, y vars, press function, and then you'll see y1. So right now hopefully you're pretty handy with your calculator, but as we practice with this, these will become second nature to you. So let's look and see what that looks like. So we're going to pull up a calculator, and you should be doing the same thing. So don't just watch and say, I know what we got going on. I want you to actually have your calculator out and do this with me. So you have your calculator, and we're looking at the function x squared. So I just did step 1 where I'm putting the function into y1. And then let's quit out of that. So once I put the function into y1, the next step is to press math. So press math. Oh, I say go to numbers. Let me correct this. Just go straight down in math. So go down to n deriv. And we press enter. And now we're going to press y1, because now we want to make it look like this, y1 x3. So vars, y vars, function, y1, and then comma x, comma 3. And this is going to compute our derivative for us automatically. And there it is. So we get the derivative right there. This says that the derivative of x squared, so the derivative of x squared when x equals 3 is 6. So let me take a picture of this. And for those of you that remember what we were doing in the past couple of days, this should come as no surprise, because given the function f of x equals x squared, we showed in the past video that the derivative function would be 2x. So if we're looking at the derivative when x equals 3, it would be 2 times 3, which is 6. So this just reconfirms what we did the other day. And so n deriv is really helpful. You need to know how to do it by hand, but here's a way that the calculator can do it instantaneously for you. And let me just go back into the notes, into the steps. Once we press that math button, we don't go to num. We just go straight down to n deriv. Okay, so we've looked at 2 different ways now of finding the derivative. The first way, which was a new way, was finding the symmetric difference. And it's very similar to our understanding of derivative before, but now instead of looking at the point A, we're looking at 2 points to the left and right, infinitely close. And this was done by hand. And then this nice calculator function, which I think you guys are going to, once you sort of get the keystrokes, will greatly enjoy. Here's a way that we can use the calculator to get the derivative without doing any work by hand. And in the next video, we're going to look at 2 other ways of finding the derivative.